Hello everyone. In this episode we will implement our break input and break output connections, and because I called this guy node schema connection, I will implement them in here actually, although it completely defies the purpose of having partial classes, but I can export them in any partial class anytime I want. So break input connection, we say related node dot break input connection for input dot related input. This is the very first thing we do. Then we say if input dot parent node or parents does not equal to null, and input dot any parent. So we have any parents there, and after everything we still call another helper method that calls reset, and we don't have it yet. Now here we go for a loop. So for each inside input dot parents, we call it parent, we say var parent output equals to parent dot outputs. Then we go another for each inside parent outputs, var we call it output. Here we say var connection key equals to the output dot connection dot list. Now we go for yet another for each loop inside our connection key, and I misspelled it anyway, var, and we call it key. And let's correct the spelling. This is connection keys. So now that we have each key inside our output, we first say key dot values dot remove, and here you see that the remove asks for an index for an int. We say inputs dot index of and I think I need link here. Node input schema, node input schema, or maybe not. Let's see. Yeah, the very first overload asks for a node input schema, and it is actually, I think, system.link somewhere. Why are you not showing it? The namespace. Anyway, I'm sure it's link. So we sent in input. That's how we get the index. After that we say if not key dot values dot any in system link, meaning that, remember, we removed the input from the values. Okay, if there is no more thing, it means that this was the only connection. So we say connection keys dot remove the key, and we say output dot child node dot children, sorry, dot remove this. Why I'm doing it this way? Because if you remember the previous episode when I showed you this diagram, and here I'm breaking connections on inputs, so we are removing connections here. And why are you not drawing? Come on, draw, buddy. No idea. Come on, draw. Will you draw? I said. So we are breaking the connection here. What I'm doing is that I'm tracking back this output. So if you look at the code, what I'm doing is that I'm getting the key from each output. So basically what I'm saying is that, hey, how many outputs are connected to you? More than one? Okay, loop through each of them, find their connection keys. Okay. Now, inside the connection keys on this output, look for me. Okay. So look for me. If I'm there, remove me. Now track it back to the output. If I was the only connection in this output, then this output is not occupied anymore. Okay. So remove the key, because the key is what is tracking the node itself, not the input. So I'm saying, hey, am I the only input connected to this output? If that's the case, then completely remove this node from this output's keys, and then on that output, remove this input, okay, from the children, this node from the children, and remove the key inside its connections. So basically we are completely flushing out this output's data, because we were the only input that were connected to this output at all. I mean, this input is not connected, okay? We were the only node that were connected, and this was the only input that was connected. After you are done, loop through and look for the other outputs. Okay? That's this piece of code right here. But after that, we are not still done. We say if not output dot any child. So if by removing myself this node from the children, the children list is empty now, then output, output, not Pete, output that is occupied equals to false. Remember, is occupied is the flag that we are using just to draw the node's skin, nothing more than that, okay? And we break out of the loop, out of this loop, this for each loop, because we already defined that there is no more thing inside that output, so there is no point in tracking anything else. Go back to the next output. Okay? After all of this nested if, so let's read everything. We first looped through every parent that we have. So we are first tracking every parent that we have connected to this input. No, sorry, to this node. Okay? Every parent, no, to this to this input, yeah. Every parent of this input node, not the node. Then loop through each parent first, look into its collection of outputs, loop through each output, and take a look if we have connection. That's what we are doing. We are looping through each parent, we are looping through each output, we are looping through each connection key inside that output. When we hit this point, we are sure that input is not connected to anything else. So it's time to reset ourselves. How we do that? Well, let's make the void reset. It's actually very simple. We say is occupied equals to false. This node is not occupied. This input schema is not occupied anymore. Then we say connection equals to new connection, and we say parents equals to new list of node schema. By the way, if you wonder how I'm doing this, parents equals to new, you see that I have tons of lists, tons of things. Basically, I'm not hiding anything. Okay, this is a very long list. Okay, what I'm doing is that when I'm hitting new, I'm using ReSharper's smart suggestions. Holding down Control Shift and space gives me some suggestions. Because this is a strongly typed parameter, ReSharper says, oh, it's just one thing that I can think that is proper, so I put it there. If it was more than that, for example, if I say is occupied equals to, and here I hit Control Shift space, you get a very small list of possibilities. But if you look, every one of them is returning only bool. Okay? So that's how I'm iterating through that long list of everything. But honestly, I think it's a bit troublesome. I may get it out of the settings that I'm playing with. Anyway, now that was breaking, where am I? Breaking input connections. The fun part is that breaking output connections is exactly the same. So I will just copy, I paste, and I will convert this to output. And why are you yelling at me now? Output, come on. Okay, so did I call it output? No, that's input. So I will select this output. I know why it's yelling at me, because it's ambiguous now. But every time I see an input, I will paste that output, and here I will convert it to input. So this will become, be careful, this will become input. Then the rest is the same. This will become outputs. And this will become output. This will become input. And this will become input. Not input, input. And input. And let me double check my notes. Yeah, basically the rest will come later, and this is the output. Okay, now outputs doesn't have parents, they have children. And any child related output, and this is break output. Then inside children, look for their parent, and suddenly everything working. So, well, I need to rename this guy to child so that everything makes sense. So inside the child, look for inputs. Then in each input, and this is not parent output, is child input. So inside the child input, select one input, get its connection key. Then for each key, check the value if the index of output is there. If it's not empty, then remove the key. Inputs dot parents, remove that. If any parent, there we go. Now the only thing remaining is just resetting our output schema. And guess what? It's exactly like this. Instead, this guy becomes children. There we go. So now we are effectively breaking the input and output on the schema. But remember, we have to do it on the node itself too. So, tons of things to do. But that's nature of graph editors. Well, why did I close this guy? Because honestly, we are gonna copy paste. So break input connection, and inside the node, break input connection, paste. Now, here we don't have this because we are just calling ourselves. And yep, basically we need to add these guys now. Well, this is the link one. That's okay. We don't have the occupied part. And that's basically it. So I will copy the break output connection too. So from here, remember the first line is redundant now. Copy, going to the node and paste and remove the is occupied part. Okay, time to add any children and any parent. Let me start with any parent. Now it's in node input, and get what it returns? It returns if parents.any inside system link, and where is that? Any child returns children.any from system.link, and then the only thing remaining is just reset. That, not surprisingly, is just where is that IO connection? Why did I close it? It's just this part. Sorry, this part, because we don't have the occupied. Okay, so this is the output, this is the output, paste, and this is not node schema, this is node. So reset inside the node input, inside common IO node input, we just paste. This is parents equals to list of node, and we are breaking our connections now. Okay, now if I'm right, our node class should be ended. Am I right or am I wrong? The only thing I forgot is that we need a public constructor without any parameters. And resharper shut down. There we go. So initialize, breaking connections, and finalize. Yep, our base runtime node class is done. Believe it. Okay, now add key. Yeah, more jobs to do. So let's go to our, if I can find my connections in my notes, there we go. And that's not that. Here we go. So going back to our node schema connection, input.add inside node input schema. All we are doing here, we say if not has, that we don't have it, not hash, has, the node that we sent in, then we say parent node or parents dot add node. Now, what is the has node has method? It's void node schema node, and I will make it public. Okay, and what it's telling us is that return parents dot contains node. So as you see, I'm breaking different link conditions into smaller parts because honestly it helps a lot this way. And now add key, we say connection key parent key equals to the connection dot list dot first or default from link. We sent in a lambda, t goes into the condition dot t dot has key for, what did I call it? Node. Okay, node dot related node dot ID. Okay, so what I'm doing, I'm looking at the runtime node because that is the node that is having the ID. The schema doesn't have the ID. Then I'm looking inside my connection list and I'm looking if I have that ID. If I find it, then return it. If I didn't find it, it will return null. Okay? Now, we say var output index equals to node dot outputs dot index of node dot parent graph dot active output. If input key input, what did I call it? Why did I call it? Yeah, input key. Where is that one? What the what? Did I call it parent key? Input key. So if input key does not equal null, we check if not has key, yet another helper method for the node with output index. Then we say input key dot add value the output index, and that's that part. Else, so if the connection key is null, we say list, not light, come on, list of int, we call it value, equals to new list of int, but we immediately initialize it with the output index as the very first param in the list. Then we say connection key equals to new connection key. We use the constructor with node dot related node dot id comma value. And where are you yelling at me? What's the problem with you? Unique ID list of int value. So what is ID? ID is unique ID, sir. Huh. Whatever. I will take a look at that later. Connection.list.add our key. Now, what is your problem? ID to list of int? What? Please show me the constructor. I replaced these. String key, move it to the left, we asks for the key then the value. That was my bad. Okay, so in the constructor of connection key, I had this overload, just sweep the place of the key then value, because that's normally how you generate dictionaries. I just went with the convention, the key then value. Anyway, now it's behaving. Okay, so what is has key? Boolean. It asks for a schema, we call node. It asks for an int, and we call it index. We first get the connection key again. So connection key, we call it parent key, equals to connection key, connection dot list dot first or default. First or default. T goes into the condition of T that has key with the node dot related node dot id. Then we return parent key does not equal to null, and parent key that has value for the index. I maybe could go fancy with, I don't know, crazy link stuff. Whatever. This won't work like that. Anyway, I could go with fancy link stuff, but who cares? If this part doesn't make sense for you, the moment I finish a connection inside the editor, I will open a node there and show you the node, and hopefully that time things will click in and make sense. So now I have a way for adding a key. Although I'm not using this API in my code, but it's nice to have a way for removing the key. Also, I will make has key to public, and I like it to be on top of the add key. So I will say public void remove key from the node, that node, not node input, node schema that we call node. All we are saying is connection dot list dot remove connection dot list dot first t goes into the condition of t dot has key of parent, sorry, I called it node, node dot id, node dot, come on, why am I doing it this way? This is dumb. Okay, node dot related node dot id. In my notes, I messed up and I was removing the key from the node, but we are doing it in schema. So, yeah. Now, I purposefully am using find here. It means that if this condition fails, I will get a null point reference exception. And that is not a bad thing, because if I call remove key on a schema and I get null point exception, then I know that, okay, that node wasn't connected anyway. That's a bit of, you know, debugging proposed there. So let's copy this guy, because now we have the same stuff. Yoo-hoo, look at this. Oh, this thing is completely mumbo jumbo. You should see my notes now. This is my notes. Tons of errors. What did I do wrong? Here. Oops. What is this thing? I'm derping. Control B, not Control V. There we go. So, let me see. We had add, we have has. I don't have remove. Let's just, for the sake of complicity, public void remove node schema node, and we say parents dot remove node. Okay, and move this has on top of yeah, there we go. So I will copy the whole thing: has, add, remove, has key, add key, and remove key. Control C. I will go into output schema and I will replace this empty stuff with that. Now, has, we say children that contains node. Add children, remove is children, and let me double check my notes for these guys. So we are asking for a node and index. We are getting the parent key here. I will call it to child key. And we are getting the list first order default node, node ID. Then we go for the child key that has the index. And add This is output key. Again, the same stuff. This will be input index that we sent. Node. Now this one becomes inputs. Index of active input. Then we say if output key does not equal null, remove from node the input index, then add the value. Sorry, if not has key, then add the value. Otherwise, list of int, list int, input index, key equals to new connection key, and add it to the list. And finally, the remove simply says remove from first, blah, blah, blah. Okay, so as you see, it's just very small code change. Okay. Now, for the actual nodes. And where is that connection? Here. For these guys. For the actual node IO, here under common IO node input. Okay? I will copy paste the whole thing again. Here. Boom. And of course, things will be different again. Copy pasted the wrong one. This is input. The easiest way is to copy this from input because of the namings. And the only thing that I need to change now is the change the node schema to the node. And here I don't have the related node. I'm directly accessing the ID. What did I do? And that is our node input. From node output schema, we go to the connection and where is that guy? Related outputs, any one of these, and paste it here. And again, this guy will become node with capital N. Copy and paste. Lazy, lazy, lazy boy. Now this guy doesn't have this part. This part. And here, what was I doing here? Input index node dot inputs dot index of. Oh. Wait. Wait, I need to double check this one. It's node IO and output. So how am I handling this here? The add key. Derp. We directly have the active input. No? You kidding me? Because I pasted without being careful. Node input, we called it active input. There we go. And the same problem should be here on node inputs. Yeah, you see, basically we don't have graphs inside here. So here we ask for node output as active output. And that is why if you go back to your connection now, you see that I was sending in extra parameters here on add keys, because when we are going to the base node runtime one, we don't have any graphs, so we don't have ability to call the active output from the graph. Okay, that was the reason. Totally lost. Okay, here. Now we don't have this part, and we don't have this part, and we are done. Yep. Let me check my node inputs outputs. Well, I had tons of extra helper methods that really is not using it right now, but I think I will use it later when I will use it when I'm retrieving values. Okay, so we still have jobs to do with our IO classes. I was just double checking that. We are finalizing our breaking. So in this episode we effectively broke our connections and implemented these missing basically from here to here, implementing add key, those methods. And right now, honestly, our node graphs should behave, but we don't have any way of seeing it unless I do something like this. Come on. Oh, derp. Let me go into our node schema, and am I hiding the flag? Yeah. Don't do it. And inside node, don't do it yet. And build solution. Successful. Now I need to delete this graph. Come on, delete the graph. Yes. And I will create a new graph. Whatever. So let's go with the easier one. Or I will create a test there and a tester. Okay, so I have two test nodes. And I'm starting to make connections. So I will right now have wait. Yeah, I can't show it on here. I know what's going on here. Okay, so editors, I need to show it here. Okay, I'm not sure which one is which, but we will find out. So if you look, each input has element. Each element has this connection. The connection has a list that is right now 0. Okay, let's make a connection. Right now I know that I made a connection. Let's see which one got the connection and where. Huh. Okay. What's going on here? Sir, output 0 to input 0. Let's see. Parents 0, related inputs, connections, list 0. Okay. Huh. Interesting. Let's see. Okay, input 0 is not occupied. Outputs 0 is not occupied. Something's wrong here. Okay, let's double check our code. Something's definitely wrong there. We are not caring about that, but let's check our first where is that node? There, node, test node. First, you see that our test node has no input output. That is bad. But test node schema, let's give it only one input and one output to make things much simpler. And it's multi-connectable, so I think it's multi-connectable by default. Am I not? There, ping. I think it's false. And I don't see my multi-connect at all. What? Did I miss it? Oh, I know what's going on. First of all, is valid connection? We are returning false. Make it true. And let's go one by one, okay? Build solution. Now, I need to delete the nodes, but I don't have any way of doing it right now, so I will delete the graph. I will create another graph. I will create a test there. I will create a test there. I will connect this test to here. And I'm not getting any connections. Meaning that another part of my node stuff is wrong. Yeah, there we go. When we are clicking on the outputs, we don't want this once connection. That was it. Build solution. One more time. Now it should be able to do it. Yeah. And there we go. There we go. Now we got the connection. First of all, I know that we got the connection because the node, the input and output graphs are changed. They are showing occupied. Okay. Now, let's take a look at our schema. Here we go. So as you see, our input has one element. In connection list, we now has one connection with this key. This key is related to this parent. Remember, it's an input one. So it's this node. This key is related to the other object. Also, the values. The value we have 1. It means that only one output on this node is connected to this input. Okay? So let me double check where am I doing that multi-connect thingy very fast. Where are you? Okay, yeah, they are true. Okay, so if I change this test node, wherever it is again, to have 2 inputs, no, 1 input, but 2 outputs, okay? And I build it again. I come back here. I will delete the graph. I will create a graph. I will create a test, and I will create another test. Now, I will connect this output to this input. Okay? Let's first find which one is the one with the input being occupied. That's the guy. Okay? Right now, I have one key with one value. Now, take a look. I will connect the other output of the same node to this input. I still get another connection, but take a look now. My connection key is the same. I get 2 values for each output index that is connected to this input. I will connect another test. I will connect its output to the input. I suddenly get a new key being generated for me with the values of 0. And I will connect this guy's output now, and I still am able to connect more than one output from same node to one input, and more than one node to one input. Okay? So now when I want to break this connection, now it does make sense. For example, when I'm breaking the connection on the output, okay? What I'm doing is that in this output, I'm looping through every input that it's connected to, because, you know, the same situation can rise, like I'm rising this guy to here now. So if I be able to select this node, if I find one, which one is that? There we go. This is this node, I think. Wait a minute. One output should have more than one input. It should be this guy. I think so. This guy's output. Yeah, that's that one. Okay. So in this condition that I connected one output to 2 inputs, I will loop through these guys, and I will remove these indexes from each key respectively. So I will remove that element 0. So it would become, you know, 0 here. Then I say, okay, hey, if this value is 0, then remove this key, and it will become 1. Then I will say, okay, break this guy, no more values, remove this key. and I effectively broke the connection on here. Okay, and of course I'm removing these guys when I say that, okay, there is no key related to these guys, so this will become 0. And then I check, okay, there is no children, no connection, no occupation, so it becomes unoccupied. And I effectively broke the connection here, although I will do the same thing looping through the inputs at the same time. Okay, if this didn't make sense at first, watch video more than once, and it will make more sense when I draw the connections in next episode, and you will see that those connections are getting broken and things will start clicking in your brain. But until then, have fun everyone. Bye bye.